Do I have anything controversial on my screen? No, I don't.
Oh,
We are live, by the way.
I see.
Oh shit. Edit. Day 93. Setting up the policy training loop with Isaacson Sac Labs.
Melissa.
Okay, so we need to do this. Forge task understanding worksheet. Okay, start reading this, bro.
Hmm. Wait, wait. Where are we? Where are we? Where are we? Where are we? All right. So, where am I reading? Purpose. The the project doc is explicit. Read the official force task code and write down the exact observation vector, action vector, reward terms, and termination conditions. Do not start by tuning PPO. First, make the existing system observable. What is PPO?
Proximal policy optimization.
Reproducible and understandable. That is what exercise. That this is that exercise. My bad. Read the pointed. Read to the pointed code yourself and fill in the blank in your own words. Not copy paste variable names. The point is build the point is to build the mental model, not to produce a transcript. All file path below a relative reference as a lab source in the repo or in the running instance relative to Docker, ISACSIM data, ISAC lab source, ISAC lab. The URL two classes matter: factory environment, the base, most of the actual logic, and the forge environment. Extends it, add force, sensing, penalty, success, and prediction. Whereas section says base and forge addition, read both. Forge usually calls super first, then adds on top. Observation vector, where to look? Okay, let's open forge envconfig.py, like side by side, so we can take a look.
Mm-hmm.
I think it's over there. Forge envconfig. It's wait, is this the correct one?
Yeah.
Task direct.
Yeah, bro, I had it open. Look at this. Reference Isaac Lab task
Oh,
direct
alright,
code.
yes. So then, what are
Lines
lines
104
10?
to 111.
104 to 111. So we have an observation list, and then we have the state order. The observation list has finger position, fingertip, E Linville. What the hell is this? And force threshold. Okay, we got some param. We got an observation order list basically, and we have state. So joint position, held quantity, fixed position. Okay,
Mm.
and let's scroll down.
But wait, OBS order and state order. Okay.
Yeah. Okay,
That's
and
it, bro.
then
We need to just see this list. We don't
mm,
need that.
okay, yeah.
And
I
the
think, oh, linear
factory.
velocity and angular velocity. Oh, okay, that's that. Linear velocity and
Yeah.
angular velocity.
And
Okay.
then what is the next one they're asking?
Factory. In the same 19 to
Factory.
25 up in the same one, I guess. Oh, in the factory, my bad, yeah, in the factory. So it's saying 19 to 25. So we have again the
This,
observation dimension config and the state dimension config for the factory. Oh, okay. I think the area where this will happen.
okay. How many numbers each entry contribute? How many? No, 3, 3, 4, 3, 3. Okay. Task direct factory nv.py base terms line 161. Which one is this? Factory nv.py. Okay, this one. And what is the line 161? This is the get factory observation state directory, state dictionary. Sorry.
Hmm.
So what do we do? Guiding questions, and then get observation 4GNV get observation. Line 120.
120, it's gonna be add addition, forge observation, and
What is it exactly?
depth state, get factory, and then we have noisy fixed position. So observation vectors, okay. And then we are getting position frame and fixed position to get. And there's an action clone going on, and then there's a previous action that is gonna run, and then there's an index for that. I see. Then we are gonna update our observation. Okay. List every entry in observation order for each one, what physical quantity it does, and how many number does it take up. The project's doc generic template 9.2 describes raw joint position vectors as a part of the observation. Are they in observation order? If not, what does this task use instead to represent?
Wait, list every entry in observation order for each one. I think this is the observation order. Fingertip position relatively fixed. Fingertip quantity, linear velocity, linear angular velocity, force threshold. And what is it saying? List every entry in observation order for each one. What physical quantity does it represent? And how many numbers does it take up? Check observation dim config. Observation dim config. The update to it in 4cnv config.py. For cnv config.py. So what is it trying to say over here? I'm not able to understand.
Where?
This one.
List entry in what physical quantity does it represent? How many number does it take up? Check dimension config and then update onto line 16. Where is line 16 and which file is it?
This one.
Forge. No. You are in factory right now. It's Forge.
Yeah, but Forge env config, right?
Yeah, line 16.
The update to it in Forge in line 16. What?
Yeah, dude, it's line 16.
Yeah, what? OBS update force
Force threshold,
threshold,
feed
one
force
fit
3.
force. So what are we doing? Like your answers. What?
Entry in order. List every entry in observation order for each one. What physical quantity does it represent and how many numbers does it take? Okay, let's copy it and then ask. Open Cloud Code and over here on the top.
On top?
Yeah, like on in your forge config.py, there is a Cloud button. Yeah, click on it. Yeah. And
I
then
need
let's
to log
ask,
in.
copy this, copy the guiding question and copy it over there and ask what is it.
Some misery. Are we getting any views? No views at all. OpenUSD got more views than this shit.
OpenUSD?
OpenUSD streams got more views.
Interesting stuff. You know, this is life. Let's see.
Oh, but what does it mean? So one thing that I did see over here in this video is that whenever you run the training iteration, you will see in Isaac Sim, you will see like this
Mm-hmm.
stuff like this. You see
Okay. Yeah.
in Isaac Sim, but we
Yeah.
weren't seeing that.
Dude, we did saw that like those are same robots doing the same task in different ways,
But
right?
we just saw the video, like we didn't see it in Isaac
Because we
Sim.
did not open the Isaac Sim or Isaac Lab over there. That is the output we got. If we would have asked it to showcase that Isaac Sim Lab or Isaac Lab over there, we could have seen that as well. I think we can still see that if you ask it, hey, can we see this in Isaac Lab or Isaac Sim? It's gonna show to us.
What the hell?
Angel investor at work. Yeah. Yes, brother. The curls.
I have everything I needed now. Here's the breakdown. Okay, fingertip and effector position relative to the fixed asset. Position relative to the fixed asset. A 3D offset vector. Fingertip orientation as quaternion. End effector linear velocity. End effector angular velocity. Smooth noisy force torque sensor reading at rest. Only the force per ENV randomized contact force threshold, contact penalty threshold used to penalize excessive contact force exposed as an observation, so the policy knows its own force limit budget. Total observation, order observation dimension, dims 1 to 4 come from base OBS dim config in factory ENVCHG. Hmm. Total observation. What the fuck? Think of it like this: the robot is trying to insert a peg into a hole. Hmm. Essentially blindfolded, using only touch and proprioception, body position sense. Instead of eyes, every single time step, the simulation package is up. What the robot currently feels slash knows about itself only into one long list of 17 numbers. That's OBS order. The neural network, the policy, looks at the list and decides what to do next. Okay. 17 numbers describing robot state neural network, 7 numbers motor command. Robot moves, simulation steps, repeat thousands of times, reward does the network if it did well. OBS order, it literally is literally the packaging order of that first list. Position 1 to 3 in a vector will always mean XYZ offset. Position 4 to 7 means rotation, etc. Network's input layer is fixed size and fixed meaning, so the order can never change once training starts. What each piece means in plain terms. Oh my god, bro. Fingertip position relative fix three numbers. How far off am I from the hole XYZ? Like reaching for a keyhole with eyes closed. You have a rough sense of how far your hand is from the target. How fast is my hand currently moving? Speed, not position. How fast is my hand currently rotating? How hand is something pushing back against me now, right now. This is a force sensor at the wrist, like feeling of your fingertip bumping the edge of the hole instead of sliding in. This is the key thing Forge adds on top of the base factory task because you basically can't do dedicate peg insertion well with the position vision alone. You need to touch feedback for the last few millimeters. How much bumping force am I allowed to? This limit is randomized for training, so the policy learns to be gentle in general, not just tuned to one specific hard-coded limit. Think of it as a randomized how rough can I be before I get penalized rule shown to the robot so it can adjust its behavior accordingly. Why the force stuff matters for this project specifically. Vision position alone can get you close to the hole, but the hand part of peg insertion, the actual contact alignment, is dominated by force feedback, exactly like how you use touch, not sight. Once your hand is already near a keyhole, that's the core idea. Forge is teaching you. Contact rich manipulation needs pro.
Alexa, second light on.
Hmm. This is why it matters in real something like this. Another action space will be equal to 7. The output side reads these 17 numbers in split 7 number.
Hmm. Why the force of matters for this project? Oh my god.
Read this. I'll be back.
Why the force stuff matters for this project specifically? Vision position alone gets you close to the hole, but the hard part of peg insertion, the actual contact and alignment, is dominated by force feedback. Exactly how you use touch, not sight. Once your hand is already near a keyhole, that's the core idea. Force is teaching you contact-rich manipulation needs proprioception plus force sensing. Not just where is my hand observation, but this is also why it matters for some real robot has real force torque sensors that behave like this. The config you read earlier, action space n equals to 7 is the output side. The network reads the 17 numbers in and splits 7 numbers out as the next quoted command and loop repeats. Write the user context.md. Hmm. God, angel investor, what are you up to?
What? What did you say? Telegram is no more on App Store. Come on, bro. We need to focus.
Right. But I'm still not able to understand shit. But let's see. Let's keep going. Scroll down. What is it saying over there? Right. The user context.md. What is it saying over there? Description, users goal and background for policy.
That is just for Cloud itself.
And
It's not.
insertion project. Oh, I see. So like based on this, what I understood was like we added some variables that basically helps our robot to basically get data from their sensors, and then we are computing those variables in the next steps, I guess. Once we have those variables defined, where like for factory there are some kind of angular velocity and linear velocity variables, and there are also variables for forge, that is our, I guess, our hand, and it has like variables like I would say same angular velocity and linear velocity, and
Mm-hmm.
both of them have sensors, but somehow they are connected. And in I think the next steps we are going to calculate some kind of values for those for our RL environment.
Mm-hmm.
That's what I understood till now with those variables. Like there are other variables as well, but I do not recall them thoroughly.
So
Thor- Thoroughly.
basically, the robot senses in one list. Every step, the robot checks six things about itself and hands them to the brain. Neural network has 17 numbers total. Where's the actual hand versus the whole? Which way is my hand tilted? How fast is my hand moving? How fast is my hand spinning? How hard is something pushing back on me? How rough am I allowed to be right now? So the big idea for most robot tasks, seeing where you are enough is enough. But jamming a peg into a hole needs touch, not just sight. That's why 5 and 6 exist, and wooden is a simpler task. Okay, I understand now. So basically, what it's saying is, I'll explain it to you.
Mm-hmm.
So the first thing that, oh, okay, let me, where is that list? Yeah, 1, 2, 3, 4, 5, 6. So this list, observation order.
Alexa, second light brightness 80%. Alexa, second light color. Alexa, second light color purple.
The fuck is wrong with you?
What, bro? Better for eyes. Like not
Better
too
for,
bright. I would say that. Okay, yeah, you were saying something.
yeah. I was saying this is the list, and
Mm-hmm.
this list basically represents
Mm-hmm.
this six things,
Mm-hmm.
and this basically decides The robot checks these six things about itself and hands them to its brain. So
Mm-hmm.
basically, the robot checks this values and basically hands them to the neural network after
Mm-hmm.
that.
Okay.
And I am guessing this observation order list is somewhere observation dim config update force threshold 1 fit ft force is 3. Mm, ft force and force threshold, and in factory it's not present. Okay, so that is the first question's answer.
Mm-hmm.
Second question is the project's docs generic template 9.2 describes raw joint position velocities as part of the observation. Are they in observation order? Yes, they are. If not, what does this task use instead to represent the or robot state relative to the target? Why might it be useful or more representation? That'd be a more useful representation in observation order. So it's saying over here what represents what does this task use instead to represent the robot state relative to the target? I think it is this fingertip position that
Mm.
I fixed, and because which where is my hand and versus the hole. This is the first one. So that's this, and then
Which way is my hand tilted?
mm,
Then I would say
this one.
tilted. Fingertip quad force threshold. Wait, I think what is quad? I guess that should be it. Like tilted is I think fingertip quad, I guess.
Fingertip quart is which way is my hand tilted?
Yeah. And how fast is my hand moving? That's going to be like angular velocity. Oh no,
Linear velocity,
linear velocity. And how fast is my hand spinning? That is going to be angular
angular
velocity.
velocity.
And how hard is something pushed back? I think that is speed force. And how rough am I allowed to be right now? And that's called force threshold, I guess. That's what it means over there.
Yeah.
Hmm.
Okay, and then after that, why the force stuff matters for this project? Vision position alone gets you close to the hole, but the outcome. So now I think we can understand this. How far I blah 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 blah. This is a force sensor at the wrist, like the feeling of your finger bumping the edge of the hole instead of sliding in.
Yeah, we were almost correct. Everything. Fingertip quad. What is the full form of quad?
Quaternion, I guess.
What?
Quaternion. You remember I was telling you about the quaternion rotation.
Oh, I see, I see.
I'm guessing. I don't know. Wait, but I need to understand this part. 17 numbers describing the robot state, and then that robot state goes into a neural network, and then the 7 numbers motor command. Hmm. And repeats it thousands of times. Reward tells this network if it did well. Okay. I have an idea.
Mm-hmm.
So let's say the robot is doing something, right? Let's say this is the hole, and this is the peg that it needs to insert in this hole, right?
It's all bagging.
Peg insertion.
My God. All
So
right.
if while training it's doing like some set of values, right,
Mm.
to perform this action, right?
Mm-hmm.
So for these set of values, what I think should be like it's doing some sort of training, right?
Mm-hmm.
According to this,
Mm-hmm.
let's copy this over here, right?
Yeah.
This is the simulation kind of thing.
Mm-hmm.
And what I think is, so it is basically dependent on the reward function.
Mm-hmm.
It basically tells how well the neural network is doing in performing that task, right?
Yeah.
It's giving out some sort of value.
Mm-hmm.
What my thinking is that why don't we create some sort of algorithm where this thing, when it is performing this peg insertion, so like let's say it does uh, one set of values over here, like I'm just making this box to represent this these set of values, right?
Mm-hmm.
I'm just using them to represent this box, using this box to represent them, and this basically says, okay, the hole was missed completely over here because of these values, right? And then it basically goes to the another extreme. It
Mm-hmm.
uses another set of the same values,
Oh,
but
so yeah,
very
you are getting local minimum and local maxima, like that
yeah,
kind of thing.
yeah. And
Okay.
then basically what we do is in this algorithm that we will design is we take the average
Local
of these two
local
values,
minimum and okay, we put a higher limit and lower limit.
lower limit.
But the thing is, like, it has a lot of variables. That is the problem, right?
Yeah,
You are
yeah,
saying
yeah, yeah, yeah.
you are
But
saying that. So
I'm just giving you like an overview of what
no,
I
no,
think.
but the thing is, okay, let's say we start to do it, right? So one of the thing is you have to create a global logic, right? So first you have to take in, okay, where is the insertion point, like where is the hole or whatever the place where the pet should
I'm
go,
just proposing, bro.
right?
I'm
So,
not
so
saying
like,
that
yeah,
this is
so
the
I know,
solution.
but I'm just trying to like give you an overview that okay, if this thing could occur, then first we have to create sample iterations and find that global minimum and global maximum. And I think we
Mm.
can already do it using gradient descent. Like with the help of gradient descent, you can find the optimum learning level. That okay, like at this point, whatever you are trying to do the predictions, they become pretty
Mm.
accurate, right? So that's what gradient descent is used for basically,
Mhm.
right? So I guess I think first what we have to do is first simulate and get the values and find out like for our 20 iterations or the 20 samples we did, what was the
Mhm.
global maximum, what was the error rate, and that's where
Mhm.
from that could be our starting point for
Yeah,
that.
yeah, for that we need to turn on the Brev instance
Yeah.
and
So then we
run
would have to
those.
find out the error
I'm
rate.
just trying to complete the like I'm just trying to understand everything before I run it
Mhm.
again. Like because I don't want to pay just for it to sit idle over there.
No, right, all right, no worries. Yeah, let's.
And
So are you gonna start the?
not right now. First we'll
Because
complete
the
this.
thing is,
We
it's
did
gonna take
this
a while.
one.
Like if you are planning, if you are planning to do it, then we should
No, it
start.
does not take a while because I we have
Oh,
like now it is built.
you're paying for the
So
storage?
yeah, $0.4
Oh,
per
okay,
day.
okay, all right, yeah,
It
no
was just
worries.
$0.4, so I didn't.
I see.
Let's see.
What
Yeah,
the
it's already
hell am I
built.
looking into? All right, yeah, this thing.
$0.02 per hour. Ba, 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 ba. Okay, what's the next thing? One more entry always gets appended in the code beyond what's in observation order. Find. What plus appears in get observation?
Mm.
Forge ENV.
Oh, dude, fuck. Noise.
Observation order. Find.
What the hell? Nice. Okay, alright. This is good. Nice. Alright, making sense.
Yeah, little by little.
What are you doing? Right? Is are we waiting? Oh, we are waiting for the instance to start it.
No, no, no. I'm just reading this. I've not
Oh,
started the instance yet.
okay, okay. I see.
Oh no, I was waiting to. I was trying to get this. Understand this.
Mm-hmm.
What gets added, appended, and code beyond what's in OBS order. Find where plus appears in get observation.
Dude, I will be back. I'm gonna bring my trackpad. Give me like 5 minutes. Oh. All right, I'm back. Yes, sir. My keyboard is here. The fuck. Ah, what we doing?
I'm just trying to figure this shit out. Okay. Damn, bro, this is not easy. What the fuck are you doing, bro?
Bro, I by mistake like the I did a gesture like this, so because of which it went back. Doomed by my own gesture powers.
One second, okay. Let me open my notebook now. It's high time. Okay. Oh my god, bro. What the fuck are you doing?
I am parallel tasking. I would just say that. I'm just waiting for you to like. You are you are at the code over there. Like, what should I look at right now? I'm confused.
Bro, I am not opening the code. I am just looking at these questions. Okay, answer these questions, please.
List
And
every
then make this table.
entry
Fucker.
observation order for each what physical quantity does it represents and how
And
many
stop parallelizing your fucking tasks.
number does it take up. Check. Okay, so yeah, we know we have to go to the factory envconfig.py, I guess, for that. Yes, so sorry, 4g envconfig.py.
We have already done that, bro. What the fuck
What?
are you looking?
No, like
We
we
already
no
done
no
that.
like we all like the question lists every entry in OBS order, so we already know what is the entry in the OBS order. Like
Yeah.
that's what I'm saying. So like, what is the task then?
This.
Yes, I know.
Sorry, this. Yeah.
Yeah, OBS order.
And then
And then what do we have next? The project's docs generic template describes the joint position velocity as a part of observation. Are they in observation order? Yes, like no, joint velocity is not in that observation, I guess. It only has linear and angular velocity.
yes.
Okay, and then one more entry always gets appended. Okay, wait. If not, what does this task use instead to represent robot state related to the target? What might that be? That be a more you? Why might that be a more useful representation? So yeah, this
This.
is
Yeah, we already know that one as well.
Mhm.
Let's do this one.
One more entry always gets appended in the code beyond what's in OBS order. Find where plus dot dot appears and gets
Get
observed.
observation.
First, like command F to underscore get observation, I guess.
No, we already know what that is.
Mm.
Line 120, 4 GNV. Yeah, here. Look at this.
Okay, and there is that array, right? So it's dot dot array, I guess. Wait, where is that array? Find where plus okay appears.
This
Wait,
is the
go
place
down. No,
self.
no, no, no. It's not talking about that. Go down.
Oh, previous actions, I guess.
Where is previous actions?
OBS tensors is equal to self config OBS order plus previous action.
Wait, beyond what's an obvious find where plus. Dude, we are specifically looking for that dot dot, I guess, or where. Oh, okay, previous actions. Oh, we are looking for obvious tensors. Oh, okay. I see now what it is doing. So
So
it's
these tensors are fed
creating
into the
tensors
neural
out
network.
of. Okay, and then we have state tensors for the same. But where are those tensors getting created? Okay, where is those tensors? So we are using observation order. Where is the observation order? Okay, we are using the observation order, and so that observation order will have some kind of value, and it's gonna be one dimensional, right? How, if it's one dimensional, and but we have a dictionary
Uh,
collapse. Okay, can you copy this and ask Cloud Code over here? What is the tensor look like? Like in the Cloud Code, where is yeah, this Cloud Code, the yeah, this one, yeah. Like how do the tensor value looks like?
yes, the extra one is I was right. Previous actions. OBS tensor what it is. The robot's own last move. The same seven numbers it sent as command on the previous step. With the two of them zeroed out,
Not a new, it's not
not
robots.
all
No,
seven
no.
are real movement commands. It is not new sense about the world. It is the robot reminding itself. Here's what I just told my hand to do. Why the policy needs it. Imagine trying to catch a ball while only ever seeing your hand is right now. No memory of which direction you pushed it. You jerk around, overcorrecting constantly, giving the policy its last command lets it stay smooth, account for lag, avoid getting stuck on its momentum. What I feel right now in the seventh group. What? 17 numbers and the seventh group. What the fuck does that mean?
Where is the 17 numbers? Oh, okay. I see now. Okay. So it's saying that there's a dictionary, observation dictionary. Okay.
Yeah.
So each observation, so I would say that so your observation list is a 1D vector right now, right? So when you have a 1D vector, so you can put your those positions. Okay, right. You know what? Open draw.io. I will show you. Open any drawing tool.
Wait.
Or if you want, you can ask it to visualize, but I can also like whatever works. Oh. All right, let's get started. Oh, San Francisco started with launch an invite-only home cleaning service using humanoid robots. The rate is $30 per hour. Wow.
Mm, what the- Okay. So this is get observation function.
Okay, so
Okay.
now if you basically vectorize it, so like basically align them in a single vector that is gonna be 1D, right? And once you have that
This
vector,
is the 1D vector that you're talking about,
yeah, oh,
concatenation of
we're
24
gonna do it
number.
at 24. Why is it 24? 1, 2, 3, 4, 5, 3?
Bro, because three values of this, four,
No,
3, so
no, no, don't it. Is it like that? Are we getting four values?
7 plus, okay, 3 plus 4, 7 plus 3, 10, 13, 16, 17 plus 7 is 24. So 24 number
Oh,
vector.
24 number vector. Oh, okay, 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 okay. All right.
And
Okay.
then concatenate into 24 number vector, and then this will go into the policy neural
Neural
network.
network, and then there are seven output. Oh, okay. There are seven numbers.
Action output, 7 numbers.
Okay, then you have low level controller smoothing.
Oh, I think I know what this is. Wait, how is it getting the previous 7 numbers? So these are the previous 7 values, I guess.
No, those are like I would say, action. I think. Wait, how would we like? Those are like f of x. I would say like you are getting a 3D 7D vector, right? Our tensor can be like n dimensional, right? So you are getting a 7D vector and you are getting a certain specific output that is like seven numbers. Now you and then you are mapping those seven numbers to the next predicted outcome. Like for example, let's say you gave image and the position and everything, and then what is the next course of action that it would need. So I'm confused. What are those seven numbers? Are those seven numbers like gonna be like only velocity and all those things? Because low level controller smoothing dead zone gains, and then robot moves one physics steps, reward computed contact penalty success, etc. Store transition observation and action reward done.
Wait. Low level controller, smoothing, dead zone, reward moves, one physics tab, reward computed, contact penalty, success, etc. Store, transition, observation, action, reward, done, robot control loop, PPO optimization loop, parallel environments rollout,
Rollout buffer
rollout
collection.
buffer collection of tuples, compute advantages and return, back propagation and gradient descent, training iterations complete, save training policy checkpoint, and then okay. And back propagation and gradient descent update weights is gone to policy neural network. And store transition obvious action and reward done. This goes back to position velocities contact forces. I get it like partially. I understand it now a little bit.
Hmm.
Let me
But I
open
have like
Claude.
a lot of questions now. Like, what is the seven action numbers that we are getting? Like, we need to ask Claude Code definitely that question. That what is the seven output numbers that we are getting, and how are those action numbers getting understood by the robot, like the neural network? Like, how is it defining those actions?
Mm, Hmm. Okay, let's read this first. What is robot's own last move? Yeah, so I was right. The robot's own last move, the same seven numbers sent in the command on the previous step, the two of them zeroed out since seven are real movement commands. It's not new sense about the world, it's the robot's reminding itself, here's what I just told my hand to do, why policy needs it. Imagine trying to catch a ball while only ever seeing your hand right now. No memory of which direction you pushed it, you jerk around. Okay. Oh, okay, okay, okay. I'll be back 1 second.
Mhm.
Okay.
All right, my man.
Okay, so this is so basically this previous seven actions are basically the look at this.
Mm.
Imagine trying to catch a ball while only ever seeing where your hand is right now. No memory of which direction you push it. So like if you're catching a ball and if
Mhm.
you're going towards it, but at
Mhm.
any moment you forget which direction you were pushing in order to go to the ball,
Mhm.
you will basically not know what your next action should be.
Mhm.
So, for instance, I'm pushing upwards. I'm pushing my hands upwards in order to catch the ball, but at any point I forget it. I
Mhm.
will push it down as well because I don't know where in which direction I
Mhm.
was, you know, putting force in to basically catch that ball. So
Mhm.
that's the main. What do you say? The purpose of previous action. And where is this previous? But where is this previous action in this? Where is this dictionary as well? Previous action.
Dude, that dictionary is imported from somewhere else. Wait, there's a dictionary.
Self
Yeah.
action dot clone.
Yes, that is your no. Oh wait, no. That's not your dictionary. Your dictionary is Wait, what the fuck is your dictionary? Object dect is your dictionary, dude. Object dect.
I
Like,
know that, but
yeah.
it is
Dude is taking an array. Like I think. Wait, what is that? Okay, object dect, comma. Oh, we are picking up only previous action from that object did, and that previous action has uh, an array, and we are defining 0.0. Yes, why are we defining that from till 3 to 5?
okay. Let it be. We'll
Hmm.
figure it out later. Hmm. And the last question was, where does this noise get added to these observation, and why would a task deliberately corrupt its own sensor reading? Look at 4GNV.py, compute intermediate values. GNV.py. Okay. So what is it? Oh,
What happened?
nothing, bro. It's just very hard. Like,
Yeah, dude. Day one is gonna be hard, and then day.
bro, this
Uh,
is day 93.
no, no, no. Day one was for OpenUSD, right? You are now doing something else. That's what I would say. Like you, now, earlier you're doing something else. Now you're doing something else. So yeah, definitely it's gonna be like trickier. Like we did understood something. Like now we know what kind of tensors do neural network takes for robots, right? So eventually it's gonna make sense. Like earlier we did not know that what tensors are gonna be going in and what are the values that tensors will hold. So now we know like what are the tensors and the values that a robot needs. Like we need to know the linear velocity, the angular velocity, and then the position related to the environment or the other fixed geometric positions, right?
Let's see. Where noise gets added, three spots, all in compute intermediate values. Subgraph, truth, ground truth, simulator values. Perfect from physics. Mm, okay, let's see this.
It overlaid it over it, I guess. Yeah, there we go.
What the fuck is that? Fingertip midpoint position, fingertip midpoint caught for sensor smooth. Gaussian noise 0.25 millimeter, small random rotation. Okay, noisy fingertip position, finite difference, fed to policy as observation. Okay, but what the
Fingertip, midpoint, quant. Okay, that contains noisy fingertip. I think noisy fingertip is like it's the random variation it will introduce for that fingertip relative to whatever data we would have. Okay, okay. Once we have that noisy fingertip, we are gonna feed it to the policy as OBS observation
Uh,
and related to the fixed position. Noisy force, noisy fingertip position. Okay, okay. So we are introducing noise, I guess. Oh, we are introducing Gaussian noise over there. That's why. Oh, that's why it's calling it noisy fingertip. So it makes sense. Wait, let me just verify if I'm understanding Gaussian noise correctly. Gaussian noise. I think I have heard about this principle. Okay, so Gaussian noise is a random variation whose value follow a normal, a bell-shaped distribution. Most sample lie near the mean mu, while the larger positive or negative deviations become progressively less likely. Okay, so Gaussian noise describes the amplitude description, not white noise additionally. So why do we add Gaussian noise?
oh,
We add Gaussian noise when we want a system or model to tolerate small random changes instead of. Oh, okay. Dude, we are trying to introduce Gaussian noise in over there so that we can go and look for the extreme scenarios like different kind of variations for the same hand. That's why we are introducing the noise. Okay.
so it's saying fingertip position line 68 to 73. Okay. Add noise to fingertip position, position level, blah 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 blah. True position plus Gaussian noise. True position plus Gaussian noise. Um, Noisy fingertip position. Fingertip rotation 75 to 84, which is right down there. Okay. Repeat infinite differencing with noisy fingertip positions. Instead of reading true velocity, it's computed by finite differencing the already noisy positions. So noise silently leaks into linear velocity and linear, angular velocity too, even though there's no separate velocity noise line. Force line 115118 true smooth force reading Gaussian noise noisy force. These noisy versions, not the clean ones, are actually what get packed into observation dictionary and shown to the policy. Meanwhile, the parallel state used only by the critic during training, never by the deployed policy, keeps the clean, true simulator values but deliberately corrupt your own sensors because the real robot sensors are never perfect. Encode jitter, force torque sensors have electrical noise, vision based pose estimates wobble by fractions of millimeter. If you train the policy on flawless simulated readings, it learns to trust precision that will never exist outside the simulator. Oh, okay. So this jitter is basically introduced so that the robot is used to the faulty readings.
Yes, and then it knows like, okay, what is wrong and how to correct it. Like we are gonna introduce those noises so that it can self correct those noises out when the model is trying to predict. Like the neural network knows, okay, this is wrong, so the neural network is already trained on noisy data. So the neural network already knows that, okay, at this point this is like a wrong thing that we're trying to do, like because we are trying to introduce RL, right? So whenever we are trying to introduce RL, I guess these noise will help us eliminate, because we are not going to reward it for doing wrong things, right? So these noise will help us give the input that it requires when it is wrong, and then we correct it. Then we showcase them with the right example as well. That, okay, this is the correct example, and then we reward reward them accordingly with the reward function that we have.
Okay, so this is deliberate domain randomization by injecting realistic sensor noise during training. The policy is forced to learn a strategy that's robust to imperfect feedback, nudging towards the whole roughly, not relying on knowing its position to the micron. It's practicing under the same fuzzy conditions it'll actually face later. The clean values aren't thrown away though, they go to the critic, the part of the network that only exists during training to judge how good the state is. The critic is allowed privileged perfect information because it never has to run on real robot. The critic is allowed privileged perfect information. Okay, wait. The clean values aren't thrown away though. They go to the critic, the part of the network that only exists during training to judge how good a state is. The critic is allowed privileged perfect information because it never has to run on the real robot. Only the actor policy does. And that's the one being trained exclusively on the noisy version. This split noisy actor privilege critic is a common trick. It speeds up learning without cheating, since only the noise hardened policy actually gets deployed. Hmm. Okay, what does exactly domain randomization mean? To work well in the real world despite the reality gap between simulation and reality. The core idea, instead of trying to make your simulator perfect to match reality, you deliberately randomize lots of aspect of the simulation across training episodes, lighting, texture, color, camera angle, object mass, okay, blah 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 blah. The policy trained under all this variation has to learn from features and behaviors that are robust uh, to those changes. If the real world just looks like one more variation with a huge range and the policy already saw in simulation, it generalizes to it rather than overfitting to the specific quirks of one simulator. Visual textures, dynamic mass scene layout. Okay. Two flavors, visual domain randomization, mainly for perception, example training and object detector on vision based policy so it isn't fooled by texture. Dynamic randomization for control policies, they don't overfit to one specific set of physical parameters. Dynamic randomization and visual domain randomization. Why it matters for SimTutorial, it's one of the main tools alongside the identification. Um, hmm. Okay, I think I understand this. This document is good, bro. Like, this is helping us to understand the whole thing.
Hmm.
But I still don't know what train and play and actor and critic thing means.
We will get it there soon. Don't worry.
This one. The dog is blah 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 blah. Everything we've done 1 to 6 blah blah blah. Pure influence, zero research content, intention. The four layers. Isaac Sim, physics plus rendering engine. Isaac Lab wraps the simulator into an RL environment. Defines observation actions, reward resets RL games PPO, the learning algorithm. So the learning algorithm that we are using right now is RL games and PPO. What is exactly RL games and PPO? Okay, our task plus reward, ablations, and the actual portfolio contribution. Only the bottom layer is ours, and the top three infrastructure we verify and then trust. Okay, what Isaac Lab actually does for us, Isaac Lab's own concept of on its own has no concept of reward or episode. It just simulates physics. Isaac Lab is the layer that turns into something an RL algorithm can train against. For our task, Isaac Lab via Forge peg insertion task we are building on defines four things: observation space, action space, reward function, and reset function. Reset termination logic, sorry. Observation space is joint positions, velocities, end effector pose, peg relative to socket pose, previous action and force, aware policies, contact force, and then delta x, delta y, delta z, delta roll, delta pitch, delta yw, a small nudge to the end effector pose per step, weighted sum, approach plus alignment plus insertion progress plus success bonus, excessive force penalty, action penalties. Weighted sum, approach plus alignment plus insertion progress plus success bonus is okay. Reset termination. How a new episode starts, randomized peg pose, and what ends. Okay, it also runs thousands of copies in this environment in parallel on GPU at once. Okay, this is why RL training is fast here instead of taking days. Instead of one robot trying one insertion at a time, thousands are attempting it simultaneously in every step. What PPO actually means in plain terms, proximal policy optimization is the algorithm that turns the robot tried something and got a reward into the robot gets slightly better at deciding what to try. Two network actor Two networks work together. Actor looks at the observation, outputs, and action. This is the policy. The thing we are actually training will eventually deploy slash evaluate. Critic is estimate how good is the situation roughly. Exists only to give the actor baseline to compare against. So I got plus two rewards becomes more useful. Wait, what? Actor looks at the observation, outputs, and action. Looks at the observation and outputs and action. This is the policy. This is the policy. The thing we are actually training and will eventually deploy slash evaluate. Estimates how good this situation is roughly does exists. So critic is basically like an eval, I
Yeah.
guess. It exists only to give the actor a baseline to compare against. So I got plus two reward. Becomes the more useful. I did better than expected or worse than expected. This cuts down the noise in the learning signal. The proximal part is the key safety mechanism. After collecting a batch of experience, PPO nudges the actor toward. Okay, is the key safety mechanism. After collecting a batch of experience, PPO nudges the actor toward actions that worked out better than expected. But it clips how far the policy is allowed to move in one update. Without this, a single bad batch of data could wreck a policy that was already working. Practical analogy, a coach adjusting your free throw. Okay, wait.
Okay,
Without
what's
this, a single bad batch of data could wreck a policy that was already working. A coach adjusting a free throw form after watching a set of shots, small corrections each round, never a total overhaul from one bad shot. Okay. Hmm. N parallel ENVs, randomized peg pose. Hmm. Hmm. So let's see what this is now. So it's a gradient reinforcement learning algorithm. Currently, the default workhorse for most continuous robotics, RL, locomotion, manipulation, sim to real policies. The problem to solve is knife policy gradient methods take a step of gradient ascent, unexpected reward, but if step is too large, the new policy can collapse, visit bad states, generate garbage data, and never recover. Since RL data is on policy, one bad update poisons future data collection too. PPO's fix it bounds how far the policy can move in a single update using clipped objective. It computes the probability ratio between the new and old policy for actions taken and clips that range clips that ratio to a small range. Example pointed 1.2. This means if an update would push good actions probability up to aggressively, gradient signals get clipped, flattened, preventing destructively large steps. Wait. Manipulation. Knife policy gradient methods take a step on gradient ascent. Unexpected reward. But if the step is too large, the new policy can collapse, visit bad states, generate garbage data, and never recover. Since RL data is on policy, one bad update poisons future data collection too. Okay, PPO's fix. It bounds how far the policy can move in a single update. Using a clipped objective, it computes the probability ratio between the new and the old policy for actions taken and clips that ratio to a small range, example 0.8 to 1.2. This means if an update would push a good actions probability up too aggressively. This means if an update would push a good actions probability up the gradient signal gets clipped, flattened, preventing destructively large step. Oh, okay. Proximal policy optimization. Now I get it. Key properties that makes it popular only needs first order gradients unlike TRPO its predecessor, which needs costly conjugate gradient KL constraint step, simple to implement, relatively few hyperparameters, works with parallelized simulation. On policy, collects a batch of rollouts, does a few epochs of mini batch SGD on that batch to throw away. Repeats, it's not more sample efficient algorithm out there of policy methods like SAC can be more sample efficient. But it's stable and scales extremely well with parallel simulation, which is why it dominates robot locomotion manipulation training, where you can run 4000 plus parallel environment on a GPU. RL Games is a PyTorch. Okay, what is RL Games? RL Games is a PyTorch based learning library, RL training library built for speed and GPU scale parallel training. Its library most commonly paired with NVIDIA's Isaac Gym Sim and Lab for Robotics RL. Okay, so this is specifically built for Isaac or NVIDIA's.
No, it's not specifically built for
commonly
It's
paired.
most commonly paired, dude. It's RL games. It does not say that specifically built for that.
Let's see what. Fuck is this? Context 7.
My God, funny stuff.
Oh, I think OpenAI used RL games.
Oh.
Isaac Jim. This is, I think this was Dex. This is OpenAI, bro. Dex stream.
Mm.
Oh, NVIDIA. So, what is it used for? RL built for massively parallel GPU environments. Asymmetric actor critic support common in sim to real. Critic can see privilege simulation only state true friction contact forces during training, while the actor only sees what the real robot sensor would see at deployment. This significantly speeds up training without breaking sim to real transfer. Config driven YML, which is how it plugs certainly into Isaac Gym. Lab task definition in practice. If you're doing leg robot local media stack, the pipeline usually looks like Isaac Sim lab environment domain randomization actions, PPO trainer exported policy. Mm. Okay, so this is the next action vector.
Mm-hmm.
Direct force 4GNV config action space. Okay, so 4GNV config line 96 is action space is int is equal to 7. Okay. Hmm. But what is it doing? And then factory env config line 75. Action space is 6 over here for factory env config, direct rl env config, and then action space is int is equal to 7 and 6. So over here it's 7 for the factory env config class, and here for the factory env config, okay, forge env config class, its action space is equal to 7. Okay, and then task direct forge env dot py apply action. Forge env dot py 152 is apply action. Forge actions are defined as targets relative to fixed asset. Okay.
Dude,
9.3.
you need a good temperature to sleep. Fuck. That is so.
So episode definition.
The frank arm holds the peg, the peg starts above the socket, the initial lateral offset. My god. All these things.
Proprioception. What the fuck is this? Use end-effector delta command rather than raw joint torques for the first version. Come on. Oh, I need a break, bro.
Dude, I think what's the time, dude? Fuck, bro, my AC is. Why is my AC broken, bro? Why? If it does not get fixed tomorrow, right? I'm gonna get the fucking portable AC thing anyhow. That's my plan. Hopefully, it gets fixed by tomorrow, bro.
Uh, but you need to call those people.
The thing is, the guy already came, and there was another guy that came today, but nothing. Like they're like okay, they are giving their own, uh, I would say like thoughts. Okay, this might be broken, that might be broken, and then I'm telling my landlord, and he's like okay, and I'm just sending him the photos that hey, the other end told like whatever the other guy told me that hey, you should do that and do that. I did everything, and nothing worked out. So and he says that he's gonna come back with a pad tomorrow or something. So let's see. And hopefully whatever he brings fixes the thing. That's what I'm hoping for. Well, like it really affecting. Like you do, it's fucking 85, and
Hmm.
Like it's giving me a fucking heat stroke.
It's
Heat stroke. Yeah. What the fuck? Okay. Stroke. 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 Oops.
Cops are here all the time, bro. They're right outside my apartment. By
Mm.
the way, now I have like info for my area, like the cameras and everything.
Oh my god, you hacked those things.
No, not hacked. I don't have it on my system, but like the Delhi that I get my like usually snacks or some stuff from.
Hmm.
They have like a lot of cameras, and they also like because I'm a loyal customer. I
Oh my
told them,
god.
listen, I live here.
Hmm.
I need info if anything, any shit goes down
Uh.
outside my apartment.
Then they're like, oh yeah, definitely, bro. Why not?
Yeah, like just call us and we'll see the camera and tell you.
Oh my god. Crazy shit.
Delancey bites for the win. Like two shops, both of them have the camera outside, and both of them are like good on good terms with me.
Nice. So you are secure. Do you have rental insurance? Like, sorry, renters insurance, or I'm saying renter.
Yes, brother. Yes, we can't live in New York without a rental insurance.
Oh my god.
State farm.
Oh, oh, how much are you paying?
Yearly, it's yearly thing. $120.
So then like 60 each,
Yeah,
right? No,
yeah.
yeah, not bad.
But my building is pretty secure, so nothing will happen inside
Hmm.
because they have like code gated, like
My god, gated code. The holy grail of security, right?
nobody can get in without the code or without calling or buzzing outside because there is only one door. It's secure
Mhm.
as
You don't
fuck.
have back door? Like there should not be one door. Like that's a fire hazard.
There is a back door for garbage, like the garbage thing, like where all the trash we need to throw all the trash, and I think that is connected via the like underground fire exit or something. I guess
Hmm. Alright, bro. So what have you done today, dude? Like, what's the time right now? How long have you been streaming?
it's only been 2 hours, bro. Not even 2 hours.
I know, bro, but my head is like, okay, fuck, bro. I tried to sleep in the afternoon as well, but dude, it was like 82, and I was just not able to.
Hmm. I see.
That's why I'm not able to focus that greatly, but I did understand a lot of concepts of what we have. Yeah.
Let's just finish this document and we can.
Okay, how long is that? Where are we at right now?
We are at two.
Okay.
We just need to understand the whole thing today. That's why I didn't turn on the Brev because I knew we were gonna
Mm-hmm.
not do anything.
Mm-hmm.
Oh fuck, bro.
So yeah, let's complete it, dude. What it is, where to look into, where we at. I think we completed the action. Did we complete the action? We did complete something, right?
This was the first one we
Okay.
completed.
We have to look at the project's doc template. 9.3 describes the six-dimensional delta x, y, roll, pitch, yaw. This whole four space action space exercise. If it's different from factory best value, go find what the extra dimension control search for self dot action across forge env.py. Apply action clip requested position, and before they are sent to the controller, find both clip operation. What the real world failure are preventing, and position action are computed across relative to something. Open it, bro. Open that file, like the file that I was talking about, env.py.
That is what it's open, bro. It's
Where is it? Self dot actions. We have actions, and then it's you somewhere you wouldn't expect for a control action. So it says that okay, we have some position of those actions, and we are gonna convert it into tensor, and then we are gonna define the position action bounds, and then we're gonna use device itself dot device. This is like a library. Okay, then we have rotation actions. That is what is this? Three is to six.
the mysteries of this world.
What is the syntax? So dot action equal to colon comma 3:6. Oh, it's a three value part. So in Isaac Lab, the cell action to a slice of actions, all rows, but only columns with indices 3, 4, and 5. So the end index is exclusive. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then we are taking 3 to 5, that is 3, 4, 5. And then 10, 11, 12. Okay, how does that came in? So 1, 0, 1, 2, 3. Okay, till 6. Okay. It's a 3D, it's a two-dimensional array. That's why. So we are gonna just slice 3, 4, 5, 6, and then gonna slice 10, 11, 12. What 6? How does 6 came? 1, 2, 3. 0, 1, 2, 3. Oh, we are just slicing that part. But okay, for whole row. Okay, we are taking for the first thing, we are taking the whole row. And then we are just slicing 3 to 6 in that row. Oh, okay, got it. I understood it. I understood it.
What?
Okay. So the self dot action, right? Like this thing. So action is a 2D array, right?
Mhm.
So it will have like two arrays. It will have array in array. So like you know how array in array looks like. You have a bracket and then another bracket inside it, right? So each bracket that it has, so each element is an array in that self dot actions. Are you getting it or not?
What? Wait. First of all, why are we doing like, what are we looking at, and why are we looking at it?
So we are looking at position actions, and then it has. So we are looking for six dimensions. That is X, Y, Z, roll, pitch, and yaw. 1, 2, 3, 4, 5, 6.
Yeah,
Right?
okay.
So those
And
actions.
Forge's action space 6 or 7.
Yeah.
It is different from factory's base value. Go find what the extra dimension control. Search for self action. Okay. For across forge env.py, it's used somewhere you wouldn't expect for control action. Okay, scale actions to allowed range. So, okay, I think Claude has explained it. So, Forge's action space is 7, not 6. env config 96. Uh-huh. Action space is int is equal to 7. The doc 6 dimension template matches factory's base. So this is factory's base. Forge adds one more. Oh. Oh, okay, okay. Now I get it a little bit.
Mm-hmm.
So Forge is adding one more, but what is it adding? It's adding 1, 2, 3, 4, 5, 6.
There are only 6 over here. Forge is the one that is getting added, I guess.
Forge adds one more, confirming them 0 to 5. Our normal control ones apply action, the function that actually drives the robot. Apply action is the function that actually drives the robot. Okay, the function forge env dot py 158. So confirming them control apply action, the function that actually drives the robot only ever needs self dot action. Uh, So this is what does this mean? 0 to 4, I guess, right?
No, yeah, that's what I was saying. So the first I didn't. So like, okay, I would just say that you can ask Cloud Code. Like it's kind of complicated to tell you, but basically you have a 2D array, right? You
Mm-hmm.
have an array, and in that array, each element is an array, right?
Mm-hmm.
So the first colon selects the complete array,
Mm-hmm.
right? So each and every element that has an array will be selected, right?
Mm-hmm.
Now the comma after that 3:6, it represents the three elements, like the elements indexed from 3 to 6
Mm-hmm.
sliced on each array in that action list, right?
Mm-hmm.
So you have a 1D, you have a 2D array. So in that you have a big array, then you have multiple arrays in that. Now you're trying to slice elements from those element array, right? So when you're trying to slice those elements from that element array, you use this kind of notation, right? So first, so the first colon selects the whole array, right? And then you have the second element that has a whole array, and the third element that has a whole array, right? Once we have that, then we're going to select, okay, we just need 3 to 6 elements that are like slicing each array, right? To slice each array, so Python has that superpower that it can slice those array with the help of these kind of annotations, right? So now let's say you have 1, 2, 3, 4, 5, 6 in the first element block as an array, and then you have a second element block that has another array, and the element has 7, 8, 9, 10, 11, 12, 13. Right now, when you're trying to slice the array with the help of this, so what it will do is it will only select from the first element block where we have 0, 1, 2, 3. So we will go till 3, and then we will slice from 3 to 6. So we're going to take 3 and then till the end, or whatever the sixth element is, that is 3, 4, 5. So we will get 3, 4, 5, and then similarly we will get from the second element block that has the second array, right? We are going to select again three elements post. So we are going to select 10, 11, 12. That's it. So with the help of that, we will have a 2D array that is sliced to 3, 4, 5, 10, 11, 12, vice versa, until whatever the length of actions we have in that scenario. So the actions can be like as many as we can, but each element in that action array represents the set of 6 dimension templates that we have, that is X, Y, Z, and roll, pitch, and yaw. So that's what we are doing over here, and we are only selecting roll, pitch, and yaw as our elements for our action.
Hmm.
So the function actually drives the robot is the first three elements. So like if you take a look at 0 to 3, that means you're taking X, Y, and Z as your first three elements, and then you're basically creating a 3D array with that. And similarly, you're going to take the rest of the elements that you have, that is going to be roll, pitch, and yaw, to get the other elements accordingly. So that's how you're splitting the actions out.
Hmm.
Hmm. But if you want, you can just put it in Claude code and you'll get the same response, but with the visualization. Like the most important thing with tensor is you should be able to visualize them, otherwise you won't be able to understand. That is like one of the important thing for tensors when we are trying to learn neural networks, because like you have to think into like 3 or 4 dimensions at the same point, and you have to visualize it. If you are not able to visualize it, then you won't be able to make those kind of decisions.
Hmm.
Maninder Vatsa. Maninder Vatsa strikes again. Strikes. Coco is here, guys. Where are we on the stream? His heartbeat is pounding like crazy. Oh my god. Oh,
He's looking so trippy in the purple light.
bro. He's gonna chill. He just shitted a lot. This was a shit time. And then he was just gonna run, and then I caught him. I'm like, fuck you. Now he's in trance. So like if you flip your rabbit upside down, they're going into trance state for some reason. Like they're high as fuck.
I see.
You're like, bro, what the fuck are you doing with me? Why are you doing this to me? I'm gonna leave. I'm like, go run, go. He's gonna run now. He's gonna go back into his den, chill over there, eat some food, fuck his
Hmm.
bitch.
Bro, he should get another rabbit for him.
Dude, we should not get another rabbit. Dude, they're gonna create a whole mess. That is the thing. They're gonna fuck around all the time, and then they're gonna shit. Like it's like chaos. And like for a small house, you should not like. My supervisor has a whole rabbit fam, so he usually breeds them, kills them, and eats them. So he's like, dude, if you have two rabbits, they're gonna fuck a lot, and then they will have more rabbits, and they're gonna fuck a lot more. And they shit a lot. They shit like crazy. The only thing that they do is eat, shit, and chill, and then fuck if they have a mate. So I think our angel investor got his balls chopped off, I guess.
Oh yeah, then it's fine, right?
Yeah, then it's fine. But I don't know. I think because like my supervisor, like if you bring a rabbit into a female's rabbit area, that female rabbit is gonna chop his balls off, and then he will be like running with blood all over the place.
What the fuck is
Yeah, because
wrong?
like for them, like it's like okay, if you're bringing a rabbit, should not go into female's nest. Otherwise, it can be chaos. That's what he said. I don't know if it's true, but male female chaos.
Unfixed male female rabbit kept together lead to immediate hormonal chaos, unwanted litters, fierce territorial
Can
fires.
the female chop the male's ball off? You can ask that. Dude, what the fuck, dude? Oh yeah, spay neuter.
Fucking hell, bro. Out of all the animals, our angel investor chose a rabbit.
Dude, because rabbit are like low maintenance animals. Like they do not require that kind of attachment and all those things. Like they can, and the way the shit is like you can make a robot suck in that shit, but for a dog it's not. Okay, bro.
First dog recommendation: Labrador Retriever, Golden Retriever, Cavalier King, Charles Spaniel. What is Charles Spaniel?
I don't know, man. Do you remember the dog that we saw at that coffee meetup?
Which
Good dog.
Bernese Mountain Dog. That's also pretty cute.
Hmm. All right, bro. Let's get back. We are getting distracted again. I don't.
Boxer. I should get a boxer.
Oh yeah. I don't know.
Golden
Oh,
Retriever.
golden retriever. Yeah, great. Then I want a dog that
Like
can
the most
beat
popular.
the hell out of another dog. Like fuck you, bitch. How could you?
That is a Doberman or a Rottweiler. I'll show you. This is a crazy dog.
Yeah,
Doberman. This dog fucks up everyone. Or Belgian Malinois. This
man.
one.
Oh shit. Oh, Belgium. Oh, it's like German Shepherd.
Yeah.
Hmm.
But this is like very aggressive dog. Trained but very aggressive.
Nice.
My grandfather had a German Shepherd. It was pretty cool.
Hmm.
He bit me once.
Oh damn. Yeah. Okay, I can get this dog if I plan to. Like my goal is to get a husky if I am living somewhere cold.
Husky is like a little, I don't know, bro. Like Husky is just a show off dog. I feel
Dude,
like
huskies are really smart. Like that's the thing.
they're smart, but they're very dramatic as well.
I'm missing drama in my life.
Rottweiler. This is another one. I'm a Rottweiler. I love this song, SD Kid Rottweiler.
I'm a Rottweiler. Wow. Don't play it, bro. Don't play it. Otherwise, the stream will get ended or you're fucked.
Oh, bro. Your software does not have the audio.
No, dude. But let's see, dude. I'm telling you, like, if the algorithm will catch it, and then like, bro, fuck you, bitch.
Okay, let's continue. Whatever that was. Oh, fuck. Of these. Excuse me. What does the forge adds? So confirming them 05 normal control apply action. The function activated as a robot. Okay. So only your index 5 actually moves. Index 6 is never sliced into apply action at all. The controller literally cannot see it when index 6 actually gets used. The surprise only in get rewards for CNV 4 GNV 251. Okay, rewards. Policy success spread. Self action sliced by 6 plus 1 divided by 2 rescale from -1 comma 1 to 0 comma 1. Policy, okay, it's not motor command at all, it's network predicting its own success, that is on a scale of 1 to 0, 0 to 1. How confident are you that you just results? The prediction is compared against the real ground truth success, true successes. Oh, okay. Mm, Computed from privilege simulator info policy itself never sees the mismatch is fed as a penalty. Oh, so here is the reinforcement learning taking place. Privileged simulator info
Hmm.
policy learns and the mismatch is fed back as a penalty at two
Argue
seconds.
that you have finished inserting the peg. The prediction is compared against the ground truth success.
Log4j metrics even tracks this like a binary classifier precision recall of the policy self-assessment 346 to 388. 346. Okay. Okay. Why hijack an action slot for this instead of separate output? VPO style training in ISAC lab is built around one action head. With a fixed distribution, there is no separate confidence output wired with the training loop by default, so for surprise repurposes. One dimension of existing action vector to smuggle out a single second signal trained purely through reward function, reward shaping to become an honest self-report. The real payoff on a real robot, you can't peek at ground truth simulator state to check did the peg actually go in. You only have noisy sensors training the policy to predict its own success from those same noisy observation. Gives it a built-in deployable way to say think I'm done without needing privileged information at test time. I see. Okay, can you explain in simpler terms what the purpose of these factory base is and what does the forge add? And
Loyalty, loyalty, loyalty. Loyalty, loyalty, loyalty.
loyalty.
Loyalty, loyalty, loyalty.
Move my hand a little bit in this direction, a small step. Roll, tilt. Okay.
And how much does the unitary robot cost?
Then 12,000, I think.
I don't know about like a humanoid robot, but I might be able to convince my team to get a robot dog or something like a helper dog.
Why, bro? Why would they get convinced to do that?
I can just give them a good explanation that hey, blah 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 blah.
13,500.
Yeah, dude. Like, if I'm able to convince, I don't have, like not for now. This is not a thing that it will get done so soon. It will take time. Like maybe 6 months, but after 6 months, I might be able to get the dog funding or something like that.
Oh, this is the Galgotia's university.
Mm.
But, oh, bro, this is actually something we can buy.
Yeah, I know. Like that's cheap, but it's without controller. What's without controller?
With controller, it's 3,000. What the fuck is it doing? But embodied AI. But what's the use? What are we gonna do with this?
Dude, I'm gonna keep it as a pet dog. What else?
You
Fun stuff, bro. Fun stuff. And
real
then I
time.
will let you know my I have a dog, but it won't shit and it won't do anything, and this is the future. And low maintenance where I can train the dog in any manner.
Digitally.
Yeah, but it's using LiDAR. That is interesting. Oh, but yeah, we have to detect object. It's not like car.
Make decisions for what? Like there is absolutely
Shitting. Make decisions for shitting, bro. Shitting. Let's do it. Loyalty, loyalty, loyalty. Oh, DM.
upgraded by 150%. 3D LiDAR mapping. Oh, this is the same technology as your vacuum cleaner.
Oh yeah, my vacuum cleaner also uses LiDAR.
40 average. I'm still not. I don't know what else. Like, why would somebody buy this?
Just for fun, bro. Like
No.
it's okay. So one of the use case I can come up with is someone who loves to go on hiking and trekking, and they do not want to have their own dog,
Mm,
right? Or like they're like a dog is like really costly. No, like maintaining a dog is really costly and all that bullshit. You have and you have to train it. Oh, this seems fun as well.
for
Oh, this is
4,900.
oh Iron Man R1. Yeah, bro. What if only if?
Speech and vision integrated model. Intelligent pioneer agile motion. Bro, is this something that we can tweak with? I think
Yeah, bro. We
all.
can tweak with it definitely. This is like what we will do in Sim to Real.
Yeah, that's what I'm asking.
Yeah, we can tweak it. Definitely, we can play with it.
Let me ask Google. Oh. Hmm. Okay. One step at a time. Let's come back to this. Okay. So factory base six numbers. Think of them as nudge, not destination. Each step, it's a small incremental adjustment, like someone guiding your hand towards keyhole with tiny nudges, bit left, bit down. So, okay, so delta x, y, and z are directions in which we need to move, and then delta roll, pitch, and yaw are the tilt my wrist a little bit this way or something like that.
Hmm.
So, what forge bolts on the seventh number? Not movement at all. It's the robot guessing out loud on a scale of 0 to 1. I think I just finished the job. It never reaches the motor. It only gets read later when calculating the reward. It only gets get read later when calculating the reward to check if the robot's guess matched reality. Where this fits in the bigger picture from the diagram earlier, 24 numbers, position, tilt, speed, spin, touch, be gentle, limit. Last move, neural network, you are here. This is the step we are discussing. Okay, so we are in the neural network. So this is the neural network we are discussing right now.
Yes, we are discussing the neural network right now.
Okay.
Discussing.
Hmm. What comes next? Six real numbers get smoothed by low level controller and turn it into explain the implementation of the neural
What is the weather outside? Is it
network.
cold? I think, dude, my room is gonna be fucking hot. Oh, it's 76 right now. So, oh, it's gonna rain. It's gonna rain tomorrow. But when is it gonna rain? Fuck. It's gonna rain after 3. Oh, fuck. That's not good.
Let me know when you want to end the stream. It's
I
well,
think
like
where are we at right now?
we are still on the second one, bro.
So let's complete the second, and then we will end the stream. Let's do that. Like we should not leave at like something in the mid of, so that when we continue tomorrow, we can start from directly freshly from 3.
And this
Right?
is we are just doing what we have already implemented, right? Like what
Yeah,
Cloud
dude,
Code.
that was the goal, right? Like first we implement it, like, and then we reverse engineer it. Like this is also like something that we have to understand, because we are able to understand, okay, what will this eventually, like we are able to visualize in a much better manner. That's how what I say. Like that was the initial problem that I had when I was trying to learn something. I'm like, okay, what is the use case for this? How does it make sense? Now, since we already know the project does this, now we know that, okay, what are the problems that we are gonna face, and how basically the neural network works.
Let me visualize this. What the fuck is this? 4GNV get observation returns policy. Okay. 4GNV dot get observation returns dict policy. Return dict policy 24 critic privilege. Gym dot make wrap 4GNV as standard gym env. RL Games adapter layer RL Games env wrapper translates dict observation for RL Games. Mm. RL Games ENV Beck ENV wrapper translate dict observation for RL Games policy vector critic vector uh, privileged. Okay. Oh, so this is the actor, this is the critic. Neural network architecture from YML, main actor critic network, separate central value network backbone LSTM 1024. What is LSTM?
Long short term memory.
Long short term memory, yes. LSTM. MLP?
Machine layer perceptron.
Are you sure?
Model layer perceptron, yeah. MLP, I guess. Right. MLP is gonna be more MLP. No, I think it's gonna be a machine, model layer perceptron. Multi-layer perceptron, yeah, my bad. Multi-layer. It was perceptron, but it was multi-layer.
Okay, and then training, execution, action, distribution, mean and spread as 7 actions. RL games, runner dot run. Drives outer PPO training loop, feedback loop. It's gone back to the. Hmm. So we know this tagged with the key policy. That's what the active, the thing that picks actions reads separately. The bigger straight order vector, the clean privileged one, is tagged critic. That only feeds a second separate network used to judge how good situation during training. This is exactly the noisy actor privileged critic split we found earlier. Now you can see it's wired up via RL games PPO config YML. What is this? Can you understand this?
Yes, brother.
What is this?
So these are our CI/CD values that we have. So starting with the batch size, that is gonna 512 of our configuration, and then we have minimum epochs, that is the number of iterations that we are gonna perform minimum, and then we have our learning rate, like how quickly or how slowly we want to learn, and for our model, and then we have our, I don't know what LR schedule, but we are going to normalize our input, so we will usually have a single array for that whenever our model is running. And then I don't know about what is network. I don't know. I think, I guess I don't. Yeah, I don't know about anything else apart from that, like RNN name unit. Okay, I know about RNN. So we have our recurrent neural network. So LSTM is is a type of a recurrent neural network. So we
Yeah,
have
yeah.
recurrent neural network, and then number of layers that network will have, that is two. And when will it be placed? So like. Where would that recurrent neural network be placed accordingly? So, for example, either is it gonna be after the RL and reinforcement or before that. So that is the placement for that, I guess. And yeah, that's it. I think that's all I know about it.
Oh, wasn't LSTM also used in? No, was it in Transformer or no?
No, bro,
Transformer is different.
Transform has attention mechanism. LSTM was an old trick that people used to increase the memory of a neural network. But it was
Mhm.
not like when you have a lot of context, like right now, it was
Mhm.
failing at that point. That's why LSTM was abandoned, and then the attention mechanism came in.
Mhm. Train.py. This is the one that I was trying to understand.
Mm.
256.
Train.py would basically have the model network that we are trying to run, I guess, like the architecture and the running script. What are you looking at?
Trying to see where this is. Oh, okay. RNN was recurrent neural network, right?
Yeah, yeah, recurrent neural network.
From that belt at each step. Standard entry point script for launching an RL Games PPO training run on the robotics tasks inside ISAC lab. It passes CLI arguments, task name, speed, number of parallel ENVs, checkpoint on resume and video recording won't be, tracking multi-GPU setting and resolves the environment agent config for chosen task. It builds the ISAC simulation environment. 1000 parallel ENVs on GPU optionally converts multi-agent ENV to single agent and wraps in RL Games VEC ENV wrapper so RL Games can divide it through its own vectorized ENV interface. It registers that environment with RL game's internal registries, build a runner, load the agent config into it. If requested, hooks up weights and bias logging. It calls runner.run and train.true. Checkpointing logging, blah blah blah. Note deprecation warning at the top means the script is being phased out in favor of ISAC lab. Underlying logic here still is identical. Hmm. Okay.
Continuous mu activation, sigma activation. Oh my god.
So the neural network in this project isn't something you'll find. Okay. 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 Apply action clips the requested position and rotation targets before they are sent to the controller. Apply action was in 4 GNV, right? Yes. Here. So what is it clipping? The requested position and rotation target. Okay, this one I guess.
Mm.
This and this.
Mm-hmm.
Oh, action and rotation action.
Yes.
What real world failure are they preventing?
Interesting. What real? I think what real world failure are the where is apply action? Apply action. We are not seeing apply action. Oh, okay, there is it. I
This
think they are
one.
preventing. Okay, what is the whole thing preventing? Fixed position frame, target finger, rotation actions. 180 unit. Not the robot's current pose directly. What is that frame anchored to? Looked at the fixed position frame. Total action dimensions. What each dimension does. 1, 2, 3, 4, 5, 6, 7. Why the policy rotation target gets clipped. Okay, we know now why the position rotation target gets clipped. Total action dimensions are 1, 2, 3, 4, 5, 6 dimensions, and what each dimension does. 1, 2, 3, 4. Hmm. What does each dimension does? Hmm.
Where
Like your answers based like on that.
total action dimensions are probably 7.
Yeah, 6 or 7.
The delta x, I think
Yeah,
these
yeah.
dimensions.
And then we have 1, 2, 3, 4, 5, 6. And why the rotation clips are getting, why are position rotation targets getting clipped? Scale actions to allowed range.
Let me give all this to Claude. How do we go back to being friends? We just share a bed. Bro, my favorite artist is coming to Brooklyn in September, but I don't wanna fucking spend money.
What is Cloud Code saying?
Look at this.
Okay, nudge fingertips along Y. Oh, fingertip
Let's.
along Y.
Here's the worksheet filled in with the reasoning behind each answer. Total action dimensions are 7, not 6. Confirmed. Uh-huh. So these are the 7 dimensions. So delta x, y, and z are just the nudges. Delta roll forced 0. The network can output anything here, but it's zeroed out before reaching the robot. Delta pitch also forced to add 0 to the same line. The only rotation that's actually free is spin and joint limit aware wrapping. Not a mention at all. Read only in get rewards in the policy self predicted. Did I just succeed? Confidence covered last time. Why the position rotation target gets clipped? Both clips. Why the position rotation target gets clipped? What is the position rotation? Oh, okay, yeah.
Uh, both
Uh,
clips.
and
Both
both
clips do
clips
the
do the
same
same
job.
job for the different axes. They cap how far the commanded target is allowed to be from the robot's actual current pose. Position clip. So pose error clipped. Oh, it was not that. Wait. Oh, this is the one. Torch dot clip. Okay, self dot delta pose, self dot pose threshold. So what is it doing? Pose error clip, torch dot clip, self delta pose, self dot pose threshold, self dot pose. Same idea for YW roll pitch separately. 205. Mm-hmm. Clipped yaw. The robot is driven by an impedance PD controller. It applies force proportional to how far off the commanded target is from where the arm currently is. Default task prop gains earlier from earlier 565 for position, 28 for rotation is if a freshly initialized or still learning network output a wild arbitrary action, the raw target could be meters away from
On
the
the
current pose without clipping. Why, what if a freshly initialized or still learning network output a wide arbitrary the raw meters away from the current pose without clipping the raw? Or try to yank producing a sudden command force talk on a real hard that means violent jerky motion actuator, blah 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 blah. Yeah, this is the proximal, this is the PPO, right? This is what PPO does.
yes, 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 yes. But the
Safety
wider
install. So
action
this is
tolerance
the PPO.
clip caps the maximum correction per step on every command and move is small, gradual, so
The
no
clip
matter
maximum correction per step to every command move is small, gradual, no matter what. No. The clip cap maximum correction per step, so very commanded move is small and gradual no matter how the network outputs. The same principle as robots, built-in velocities, force limits. Okay. Bonus the reference frame guiding question 3, fixed position action frame. Actions aren't relative to robot's own current pose, they're relative to fixed position action frame, fixed position observation frame plus initial fixed position observation noise. 166. Let's see, what is that? Fixed position action frame, self fixed. Okay. Um, it's set to the top surface of the fixed asset. Tracing this back to it's set to the top surface of the fixed asset, literally the tip of the hole bolt peg needs to go into literally the tip of the hole bolt slash peg needs to go into plus a noise offset sampled once for at the start of the episode simulating at the real robot doesn't know the target's exact location perfectly either. Some vision calibration error fixed for that episode, so delta x point 0.3 doesn't mean current pose plus zero point 0.3, it means zero point 0.3 units from where I think the hole is. That's a deliberate design choice since the fixed asset spawns at randomized position every episode, defining actions relative to it rather than in absolute world coordinates means the policy learns one consistent skill, close the gap to the target instead of having to relearn arbitrary absolute coordinates every time the new hole moves. Uh-huh.
So the clips caps the how the command target is allowed. That is our answer. Like okay, I see now.
Is the third answer simply the PPO algorithm implementation, or is it something else? Mm, okay, these are two different things. No, these are two different things. They are just happen to share the club. Every single simulation step while the robot is moving, it's bound for a physical target. Pose can be from the robot's current pose, a safety limiter on the robot motion itself. The code would exist identical no matter what algorithm trained the policy, PPOSSE, even handwritten controller. It's task environment logic, not learning algorithm logic. People's own clip is a completely different mechanism, and it's actually in the YML we read earlier. E clip is equal to zero point 0.2. Let me understand this as well. The purpose of this config for the same project. How do they relate? Uh, this is proximal policy optimization namesake track. Mm. This one club is the raw network output 2 minus 1 comma 1. Ah. There's a training update.
Oh, it's not only doing training while robot is moving.
It limits how much network weights are allowed to change in one gradient step by clipping the ratio between the policy and
And the
order
whole
policy
process for encoding
probability.
that was actually taken, it has nothing to do with robot motion. It's purely about keeping learning stable and preventing one bad update from wrecking the policy. This is actually a third clip too, and also in the same YAML.
This one clips the raw network output minus 1 comma 0, 1 before it's even under the basic sanity bound on Gaussian policy sample output sensor to technically sample slightly outside the range. So 3 layers, 3 different jobs, clips where wire bounds Y. Clip actions, RL games wrapper before enemy sees the action, raw network output, keep it in invalid. Invalid minus 1 comma 1 range, position rotation clip, apply action, every physical step, commanded pose, target versus current pose, robot safety, no violent jumps, eclip point 2.0, gradient update once per training batch. How much the policies weight and shift training stability. Simple analogy, the apply action clip is the seat belt speed limiter on the car itself. Matters no matter. It matters no matter who's driving. PPOZ clip is fuck me, bro. This shit is hard. This shit is hard as
This
fuck.
shit is hard, that's why no one is doing it.
Mm. But okay, this was the first day of trying to understand the code, so I think should be fine.
Alright, so I think we can end the stream now. I guess.
Yep.
Is it ended?
1 second.